Welcome back, everyone. This week we're going to talk about apportionment. So assume that your teacher shows up for a class with 4 dozen donuts. The class has 24 people in it. How many donuts should each student get? Well, if there are 48 donuts, 4 dozen, and we divide by the 24 students, then every student is going to get 2 donuts. This is a really simple example of apportionment. It's simple because we have enough to divide everything evenly. But what if the teacher wants some donuts? Or if there's some students absent, how would you determine a fair way to distribute them? In general, we could break them apart into pieces, but what if we had something that wasn't like a donut that we could break into pieces, something like a computer or a vehicle? We call these things indivisible because we can't divide them into smaller parts. You can only give one computer, you can't give someone half a computer. Apportionment is the process of fairly assigning identical, indivisible objects among individuals entitled to shares that may be unequal. So the most obvious way to determine how to divide things among groups would be what's called the standard divisor, which is just the total population or the total number of items divided by the number of divisions or the number of groups that it's going to. So if we were determining the number of donuts, well, the total number of donuts divided by the number of people we have to give donuts. If we're talking about things like political seats, which is what our example will go through in this section, then it would be the total population divided by the number of seats available for that population. So let's say a large city has 20 seats to be allocated proportionally among 5 different districts, given in this table. So if we want to proportionally allocate these representatives, we have 20 representatives that we can allocate. And we're going to use this example throughout this section. If there are 20 seats that need to be divided among 5 districts, given in the table, we want to do all of these proportionally. Well, first, to find the standard divisor, we just want to divide the total population divided by the number of seats that are available, and we find that to be 12. The standard divisor is just a value that we're going to use to determine how many of the representatives are going to go to each group, because the groups are unequal, and we'll see that in the next part of the example. So if we divide the population of each district by the standard divisor, by the number that we just got, we find that this is mathematically equal to the percent of the population in that district or that group times however many seats there are available. This will assign essentially a fair way of assigning representatives. It would also give you a fair way to assign items based on some weighted percentage. So for example, the owner of a corporation gets 45% of some items while the workers get 5%. The standard quota provides the value in each group, assuming that we can still use decimals. So here we can't have decimal people, we're going to get to that part. But now, let's just assume that we can still have decimals. Remember that our standard divisor was 12, and so we're going to divide each group by 12. 32 divided by 12, 2.67. 80 divided by 12, 6.67. 41 divided by 12, 3.41. 3.42, 67 divided by 12, 5.58, 20 divided by 12, 1.67. So the standard quota gives us the proportional representation, but only if we can still use decimals. Well, what if we can't use decimals? Well, then we have to round in some kind of way. So we have to round these to whole numbers, but it's not always as simple as rounding to the nearest whole number. If we round each one of these to the nearest whole number, we'd have 3, 7, 3, 6, and 2. If we add all of these up, we get 21. And there are only 20 seats available. So it's not as simple as just rounding to the nearest whole number. And there are actually different methods that are used for rounding. What we call the upper quota is just the result of rounding the values up to the nearest whole number, and the lower quota is rounding the values down to the nearest whole number. So here, the upper quota is just rounding up to the nearest whole number. So 3, 7, 4, 6, 2. And the lower quota is just rounding down to the nearest whole number. 2, 6, 3, 5, and 1. However, in both cases, the number is still not right. So here we have 22, and here we have 17. So what are some other ways that we could round? One way is using what's known as Hamilton's method, where we're just going to assign each district the number of seats according to its lower quota, and if that works, you'll just quit. And if it doesn't, you assign seats one by one to the districts in descending order of the size of fractional parts of their quotas. So that just means if you have 2.93, it would get the next seat. 4.070 would get the seat after. by looking at the decimal parts of the numbers and assigning seats. So let's see what this method would give us. So using Hamilton's method, we're going to assign everyone the lower quota, and then we're going to add representative or add items based on the decimal points. So the greatest decimal points here are 0.67, 0.67, and 0.67, and then 0.58, 0.42. We have 3 extra seats that we can assign, and so each one of the 0.67 would get 1 extra seat. And this would then be 3, 7, 3, 5, and 2, and that would give us 20 total. But this is not the only way that we could round and divide the remaining representatives or the remaining items. Jefferson's method assigns each district the number of seats according to its lower quota, just like Hamilton's method. If the sum of the lower quotas doesn't work, we choose some modified divisor, a number that's not the standard divisor, a number less than the standard divisor, and then we recalculate those lower quotas. And then we use that if those values add up to the total number of seats. If not, we adjust the divisor and we try it again. Jefferson's method is a method of trial and error. We're just going to try numbers until it works. If for some reason the sum adds up to be greater than the number of seats, then we've reduced the divisor too much and we want to increase it again. So let's try Jefferson's method. Before we had used a standard divisor of 12, now we're going to modify the divisor and divide every number by 11. It's less than the standard divisor, and we're going to see what values we get. So the modified quotas here are just the numbers divided by 11, 32 divided by 11, 2.91, 80 divided by 11, 7.27, 41 divided by 11, 3.72, 73, 67 divided by 11, 6.09, 20 divided by 11, 1.82. So the lower quotas are then just rounding these values down to the nearest whole number. So 2, 7, 3, 6, and 1. But now this is equal to 19. So let's modify the divisor some more. Now let's divide every value by 10.5. When we do that, we get our modified quotas, 3.04, 7.61, 3.90, 6.38, 1.90. And so now the lower quotas, 3, 7, 3, 6, and 1 to 20. If we compare this to Hamilton's method, we had the groups proportioned this way. So it does result in a different answer. Another way to round it is to use Webster's method. Here we're going to assign the number of seats using the standard rounding rules on the standard quota, and we're going to round up if it's greater than 0.5 and down if it's less than 0.5. If the number of seats is equal, we use that, and if not, we modify the divisor and we try again. If there are too many seats, we use a larger divisor. Too few, we use a smaller divisor. And so we just adjust the divisor based on the standard quota rather than starting with the lower quota as we did before. So we already know that just standard rounding on the districts at the beginning wasn't going to work. So let's use a modified divisor instead of the standard divisor of 12. We'll use a modified divisor of 12.5. So we're going to divide everything by 12.5. And so that our modified quota, 2.56, will round to 3. 6.4 will round to 6. Here we're just using the standard rounding rules. The modified quota is 3.28, which rounds to 3. 5.36, which rounds to 5. And 1.6, which rounds to 2. But here, again, this is only equal to 19. So here we have too few seats. We had used 12 and there was too many. We used 12.5 and there were too few. So let's try 12.2. If we divide each value by 12.2, just modifying the divisor so that our rounded values will add to 20. 2.62, 6.56, 3.36, 5.49, 1.64. If we round each of these values, 3, 7, 3, 5, and 2, now we get 20. Please let me know if you have any questions.